Okay, this one says section 7.8, but it's not. It's 8.4. That was just a typo. And it's called special products. So basically all we're doing in this section is just continuing what we were doing with FOIL or using the box. But there's going to be cases where you have problems that look like this, where it says something like two terms being squared, or two terms being subtracted and then that's being squared, or two terms being multiplied together. But what do you notice about these two right here? Yeah, they're the same number. Whatever that number is and whatever that number is the same here. The only difference is they have opposite signs in between. So these are called special cases, and we have to figure out what happens when we have special cases. So basically we're just going to FOIL these out and see what happens, even though there are no numbers here. And actually that is nice, because when you do something mathematically with no numbers, then you basically prove that it will happen every time no matter what you plug in. So the first thing I need to remember is, what does that square right there mean? Yeah, it's times itself. So like if I have x squared, what is that really saying? X times x, that's right. If I have like 2y squared, what is that really saying? 2y times 2y. That's right. So if I have a plus b squared, what is that really saying? A plus b times a plus b. That's right. The danger of a problem like this is, we learned earlier in the last chapter that if we have two things and we're squaring them, it's tempting to want to send that exponent in. You cannot do that here. Does anybody know why? Because what? Well, you'll get the wrong answer, yeah. But what's the difference between what we learned in the last chapter when we sent the exponent in and what we're seeing here? I'll write that property that I'm talking about then. A, b to the nth power. What's the difference? Yeah. On this one, we're multiplying. In that case, we can send in the exponent. But on this one, we're not multiplying. We got that addition sign there. Or like on this one, we got a subtraction sign there. This is not a product to a power. This is two terms to a power, which makes us have to do this. So now that we've done that, how are we going to have to multiply that out? No, that's exactly what I was just saying. With this property right here, we can do that, and it would become a to the n times b to the n. But here we have a plus sign in between. That is not this property. We can't do that here. Okay? So you have to write it out like this, and then you have to FOIL it. This is a FOIL problem. So you have to keep that straight. This is the biggest place where people make mistakes when they're first learning this type of a problem, how it looks. They make that mistake by trying to use that property there, and that is wrong. So let's FOIL this out, and you'll see that it's actually wrong. It's not going to be a squared plus b squared. So when I FOIL it, I get a times a, which is, right, a squared, and then a times b, which is a times b. So we write plus ab. All right, then I switch. B times a, which is, so a positive b times a, but we write those letters in alphabetical order, so I'm going to write plus ab. And then finally, b times b, b squared, so plus b squared. Now, after we FOIL, what do we have to do? Combine like terms. Are there any like terms to combine here? Yeah, which ones? The AB. I got an AB sitting here. How many ABs are sitting right here? Right here. One. And then I got another AB. How many ABs are sitting there? One. So how many ABs do I have? Two of them. So when I combine like terms, I have a squared plus 2 ABs plus b squared. Do I have any other like terms? Nope, that's it. So that is the answer. Okay, I'm going to stop and let you guys try to do this one. It's basically the exact same problem. Make a FOIL problem and then go ahead and FOIL it. All right, what should we write first? Yep, make it a FOIL problem. Okay, now we can FOIL it. Right, a squared minus ab, good. Minus ab again, good. Right, that's negative b times negative b, which becomes positive, so plus b squared. Combine like terms, and you get minus 2ab plus b squared. There you go. There's your answer. So the interesting thing about these two results is, if you notice, the only difference between this problem and this problem was what? The subtraction sign. And notice the only difference between this answer and this answer was what? The subtraction sign right here. Both wound up with a plus sign here and here. Both wound up with a squared to start. Both finished with b squared. Both had 2ab in the middle. This is why this is called a special case. Because of the fact that we use just letters here, and because of the fact that we came up with this answer that has just letters, except for that 2 right there, then you can say this. Any problem that looks like this, if you know this pattern to go from here to here, and you memorize that pattern, and you're given a problem that looks exactly like this, with numbers in it instead of letters, then you can go straight from here to here. All you have to do is square that first thing and put it there. That sign goes there. Then 2ab means take these two numbers, multiply them together, and then double that result. And write that answer there. And then plus that guy squared going right there. It's the exact same result as over here. Take this, square it, write it there. Take that sign, write it there. Take these two numbers, multiply them together, and then double the result, write it there. And then plus that number squared for that last term. It's a pattern. You don't have to use patterns. You don't have to use this at all, actually. You need to learn it. You need to learn how to handle a problem that looks like this. Write it out like a FOIL problem and then FOIL it. That's how I recommend you do these problems. But I'm showing you the pattern because in a little bit later in this chapter, we're going to be going backwards. We're going to have problems that look like this, and if you know the pattern, you can quickly go to that because they're going to be working backwards. So I'm just showing you this pattern so that you see it. You don't have to use it. You can just FOIL, which is perfectly fine with me. For this last one, let's FOIL it. It's already written like a FOIL problem, so let's go ahead and FOIL it and see what happens on this one. What do we get? A squared, good, minus ab plus ab minus, not 2b, b squared. Good. So what happens here? They're gone, right? This is negative ab, this is positive ab. If I put those together, a negative 1 plus 1 is 0. I wind up with 0 ab. 0 times anything is just 0. This stuff right here in the middle goes away. What am I left with then? A squared minus b squared. That's the answer. These guys right here, these two, the only difference between them is the sign in the middle is switched. There's a vocab word here that you don't need to know, but these are called conjugates. In Algebra 2, we work with conjugates all the time. So this is the first time you've seen a conjugate. If you recognize that it's a conjugate, the interesting thing about conjugates is when you FOIL, what happens? Which term was this one in FOIL? So what part of FOIL was that? It wasn't first. It was the outside, the O. And this one right here, the AB, that was the I. they added up to be 0. They disappeared. It's like the O and the I in FOIL disappear. And all you need really is the F and the L. So this is another special case. It's called conjugates. Like I said, you don't need to know it. You don't need to even recognize it as you're working with it. But when those two terms disappear, what I want you guys to do is remember this pattern right here and say, oh yeah, and then look back and see that they're conjugates. Okay? So in the meantime, on this chapter, basically, just FOIL stuff. Write them out like a FOIL problem. Write them out like a FOIL problem. This one's already written like a FOIL problem. Just FOIL stuff. Okay? Or use the box. That's fine if that's what you prefer. But when you get these answers, I hope that you start to see that pattern. These are special cases to only use with these types of problems. Not every problem will have this happen. Only when you have conjugates will this happen. Not every problem will have this happen, or this. So these are only special cases, and you can only use these patterns on special cases. You still have to FOIL all of the other problems, and actually, you can still FOIL these if you forget the shortcut, and like 98% of me recommends that you FOIL these anyway, even if you remember the shortcut. It's good practice, and it's worth it. So we have 9 practice problems to try here. Let's do that top left corner. I got this set up like a tic-tac-toe board. If I was feeling like having fun today, we could play tic-tac-toe. Do we need to play tic-tac-toe? Probably should. Okay, that's fine. All right, so congratulations, X. X won the game. We still have to figure out these other 4 that we didn't get to, though. So first of all, we have x squared plus 6x plus 9 on that one. X squared minus 12x plus 36 on that one. Y squared minus 36 there. The middle square was 36x squared minus 12x plus 1, and then z squared minus 9. So just to make sure we have all those correct on our notes. What should we do with x plus 7 squared? X plus 7 times x plus 7. X squared plus 7x. 7x again, yep. 49. So what is our answer going to be on this one? Very good. And this one? X minus 4 times x minus 4. Okay. Minus 8x plus 16. Good. And the one below that one. You might remember that word. What are these? Conjugates. Yeah, these are conjugates. So we get no. 9x squared. Okay, so that means my answer is, because the O term and the I term on that one disappeared. That's right, 9x squared minus 4. And how about that bottom last one that we have here? Yep. Very good. All right, so now we know all 9 of those problems. Hopefully they're correct in your notes, and we'll move on. All right, story problem time. The edge of a cube of aluminum is 4 centimeters less than the edge of a cube of copper. Okay. Write an equation to model the surface area of the aluminum cube. So which one of these is the aluminum cube and which one is the copper cube? Right, because it says aluminum is 4 centimeters less than. So the smaller one is the aluminum. Aluminium, even though there's no I before the U. And then copper. All right, so the only information that they give us, actually there's two pieces of information here. What's one of them? That's one of them. What's the other piece of information that's important? No, that's what they're telling us to do. It's a cube. All the sides are the same length. That's right. So, how long is the side of a edge of aluminum? 4 centimeters less than the edge of the copper. So how long is the copper? Well, no, not yet. We want to write out our dimensions here. You're getting a little bit ahead. You want to know what you have. It says aluminum is 4 centimeters less than the edge of a cube of copper. Well, we need to know what the edge of the cube of copper is. What is it? X or C, right? Doesn't matter what letter you use. We don't know how long that edge is, so we'll call that X. And now that we've called that X, we can call this X minus 4. Because whatever this edge was, we've got to take 4 away to get that edge. That's right. Okay, so it's the edge of a cube of aluminum. Now it's a cube, which means that this side right here is the same as this. So that's also X minus 4. And that means that this edge right here, going back, is also X minus 4. Now what are we looking for here? Surface area. Surface area means the area of the outside of all of the faces of the thing that we're looking at. So how do I find surface area? This is in a circle. Length times height times width gives you the volume. This is just surface area. Yes, that's it. The thing times 6. Why the thing times the thing? Right. We're trying to find the area of that face right there. And once I find the area of that face, what's the area of that face? Same thing. What's the area of that face? The same thing. What about the one underneath that you can't see? So how many faces do I have on a cube? 6. Which means that if I find the area of this face, what can I do to that? Multiply by 6. So the area of this face is going to be base times height. What is the base? What is the height? And what are we going to have to do to that? There you go. There's your area. It says write an equation, so we'll say surface area equals that. You would FOIL first and then distribute that 6 in. So let's go ahead and do that. So surface area equals 6 times x squared plus 16. All right, so then we should probably what? How about combine like terms? Do that next. 6 times x squared minus 8x, yep, plus 16. And now we can send that 6 in easily. Surface area, that might be the coolest looking S I've ever drawn, equals, yep. Yep. It's a tough one. 96. Plus 96. There's your answer. Okay? So, is it an impossible problem? No. But you got to do a little bit more thinking than normal on this. And you notice you do wind up with a foil-looking type problem. And then you just FOIL it out, and then you can distribute that 6 in. You guys are capable of doing a problem like this for sure. Last problem. The figures below are squares. Find an expression for the area of the shaded region. Write your answer in standard form. What is this asking us to do? Find the area of the shaded region. How are we going to do that? Well, it's not surface area because it's not a shape. Yeah. Remember, we'd had a problem with the helipad where we had the area of the square minus the area of the circle. This is like a hole here. If I find the area of the shaded thing, so area of shaded, what am I going to do with that? I heard subtract. What are we subtracting? Area of, call it white. So we got to find the area of the shaded thing and subtract the area of the white. What is the area of the shaded thing? That it? X plus 4. Good. And then minus the area of the white. What's the area of the white? Yes. And now the directions say write your answer in standard form, which means we got to FOIL both of those and then combine all our like terms. So FOIL this one. Yep. Yep. Use parentheses on this one. X squared. Yep. Yep. Plus 1. Good. Notice I use parentheses there because what am I going to have to do here? Yeah, keep, change everything as we combine our like terms. So change that, change that, change that, change that. So now we can combine like terms. Where do we start? X to the second plus x to the negative second is gone. It disappears. So these two guys are gone. What about this 4x, 4x? What do we get there? 8x. But then I got another x and another x. 10x. Gone, 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 gone. And now I got 16, negative 1, 15. So I write plus 15. That's the answer. Simplified down to that. So that's how you would do a problem like that. Just remember, if you're dealing with shaded regions and holes, find the area of the shaded region, subtract off the area of the hole or the clear part. That's it.